going, everyone? Mr. Geyser here with the first video in our Lesson 12A series on logarithmic function manipulation. For this series here, we're taking a look at three main skills and learning objectives. First, we're going to apply the properties of logarithms to evaluate expressions and then graph those functions. Two, we want to use properties of exponents in logarithms to simplify and evaluate those expressions. And three, we're going to recognize the graphical translations of logarithms related to the product, power, and change in base properties for logs. Speaking of which, let's take a look at these properties here. In general, we have these two columns here. One's for natural log, one's for common log. They really just do the same kind of thing. But I want to try and showcase what a log and a natural log might look like for it. For these fundamental properties of logs, for any positive number for m, n, and b, where b is not equal to 1, and p, that power, is some real number, the following three properties are true. First, we have the product property. The product property states that if there is two terms or multiple terms inside of the log function, their product is the exact same as that common base, that common base of log summing together. So we have log base b of m times n is equivalent to log base b of m plus log base b of n. That next one is the quotient property, and it does the exact inverse thing, where if we have m divided by n, that's the same thing as just saying log base b of m minus log base b of n. The third property here is going to be that power property, where if we have any value for n, and it's being raised to the power of some positive number p, we can just pull that p out of the log function and say that it's the product of p times log base b, the same base, of n. This is for the common logs, also any base log, as well as for natural log. Natural log is the exact same thing as log, but specifically the base of natural log is that natural number of e. Let's put these into practice with example 1. For example 1 here, we're given that we want to expand the following logarithms using those previous three properties. If we take a look at A, we have log of 8xy to the fourth power there. For me, I know that's a common log, so that's a log base 10. And I want to try and use that product property to try and separate those three terms. I have log of 8 plus log of x plus log of y to the fourth. Now notice what happens to this 8 and this y to the fourth. For this y to the fourth, it's really easy for us to see we're going to pull that 4 out of that log function to make it a product. But notice what happens to that 8. I want to rewrite that 8 as something that's exactly equivalent to raised to the third power. And now I can pull that 3 out and make it 3 times log of 2 plus log of x plus 4 times log of y. That there is my final answer. That is the fully expanded version of A. Let's try that one more time in part B. In part B here we have natural log of the square root of x squared plus 5 divided by x. Now in general for that natural log there, it's the exact same as saying natural log of that radical x squared plus 5 minus natural log x. I'm just separating that quotient inside of that natural log and using that quotient property to make this a difference. Remember that that square root there is actually going to be an exponent of 1/2. We can pull that exponent of 1/2, just like that 4, just like that 3, and make it a product of 1/2 times the natural log of x squared plus 5 minus natural log of x. Now, this is where it ends. We do not have a property or rule when it comes to sums inside of our log function. Notice how we cannot take that 2 off of the x there because we have that sum affecting that x squared. What I mean to say is we can't remove that power from that x because the term of 5 is affecting the term of x squared. Now that we have this expansion down, let's go in reverse. Now, in example 2, we're going to condense the following logarithms using these same properties we just practiced. For part A, we have the natural log of x raised to the 5th power minus 2 of natural log of xy. First thing I want to do, I just want to rewrite that problem there, just making the colors a little bit more vague, or make it less vague, make it more identifiable. I actually want to take care of this 2 natural log of x times y first. When I bring that 2 into the natural log, it's that whole thing being raised to the 2nd power. So it's xy raised to the 2nd power. So now when I use that quotient property, I'm now making it the quotient of x to the 5th power divided by that xy squared. Now what I want to try and do to simplify this a little bit more on the inside of this natural log, I kind of want to distribute that power there and make it x squared, y squared. Now it's really easy for me to cancel out those x's, saying that that 5 turns into a 3, and it simplifies out that x squared, where our final answer here really is just that natural log of x raised to the 3rd power divided by y raised to the 2nd power. Let's take a look at part B here, where part B states 3 times the natural log of x to the 3rd power times y plus 2 times the natural log of y times z to the 2nd power. First step here, I just want to rewrite a lot of these into that colored there. My first step is really just to bring those 3, or that product there, that 3 into that exponent, and that 2 into that exponent. And remember, it's going to be that whole thing raised to that power, okay? My next step is now to use that product property where I'm just, or not a product property, that distributive property where I'm just putting my power into my terms here. Now I'm going to use that product property of equality where I'm just taking the product now because of this sum of these logs here. Once I take the product of it, it's really easy to see how I'm going to simplify these y's into the natural log of x to the 9th power times y to the 5th power times z to the 4th power here. And that there is my answer for this problem here. Thank you very much for joining me on this first video for our Lesson 12A series, and I look forward to seeing all of you guys in that next video. Take care.